So now we're moving on to our next section. This is going to be sections 1, 2, and 1, 3, angles. So we're going to learn how to name angles. We're going to identify different types of angles and use a little bit of algebra with angles. So let's define what an angle is. So it's made up of two rays. So in our last lesson, you learned what a ray was. So imagine two of those, two rays, and they're going to share that common endpoint. The common endpoint is going to be called a vertex. So you'll hear the word vertex come up, and the rays are going to be represented as the sides. So here's a picture of an angle. This is an angle because you can see ray AM and ray AT. And the vertex is A, okay? And the vertex is just a point. So let me get my highlighter and highlight a couple of things. So this point right here is our vertex. Here's a ray that goes out infinitely, forever and ever that direction. And then here's the other ray. And that's our angle. So it's important on how you name it, just like we did in the last lesson. We named several different geometric terms. This particular way on how we're going to name this one is with this little angle symbol right here. Okay, so we're going to have to use that angle symbol. And you can name it with 3 letters or with 1 letter. For the most part, we're going to name it with 3 letters like this. Angle TAM. Okay, now since this is an angle entirely by itself, you can actually name it with just the vertex, angle A. But like I said, for the most part, are dealing with a picture with multiple angles at one vertex, so we're going to have to use 3 letters. Some kids will name it the opposite way. So for instance, angle MAT, and angle MAT is the exact same thing. So that's why I had only gave one example, but both of those are correct. Okay, so that's angle. We're going to talk about the measure of an angle. Okay, and so what is the measure of an angle? It's the smallest amount of rotation about the vertex from one ray to the other ray. And this is measured in degrees. So you probably did a little bit of this in middle school. So we have this angle right here, angle GPS or SPG. Okay, and so the rotation goes like this on how it rotates. It goes from here, this ray, to that ray. And so that amount of rotation is about 43 degrees. Okay, and then there's a tool that you can use to measure how many degrees an angle is. Okay, so it's an amount of rotation. You heard the word congruent back in the first lesson, 1.1. We talked about congruent segments. Congruent means same shape, same size. So when we talk about congruent angles, all this means is angles who have the same measure, okay, or they're equal. So this case right here, you have an angle GPS with a measure of 43 degrees. So that's the amount of rotation. That's about 43 degrees. And then you have angle ABC or CBA. That rotation is also 43 degrees. So then we can say that those two angles are congruent. Okay? The other thing that you might see if they don't give us an angle measure, they're going to have this little tick mark like this in each angle. Okay, so if you see those tick marks, that also signifies that they're congruent. So we have angle GPS is congruent. Remember the congruent symbol from unit 1, from lesson 1.1 is congruent to angle ABC. So this is a tool, and you might have briefly used it before, or you may not have. It depends on what middle school you went to, but this is a tool called the protractor that actually measures the angles. Okay, so it has all the degrees going around. It's like almost like a half a circle. So we're going to practice using that on this next one. So this is a tool that is used to measure angles. So let's practice using that. The thing about the protractor is, let me see if I can highlight it. Sometimes it doesn't, but that little part right there, there we go. That little part right there always has to be at the vertex of the angle. And remember, the vertex is where the two rays meet on that endpoint. So that goes to at the vertex, and you have to line up the 0 with one of the edges. So let's practice that. So I bring it over here, and you have this picture on your notes so you can follow along if you have a protractor. So if I'm going to measure this angle over here, let me mark it right here, angle AEB. I'm going to place the protractor with ray EA on the 0. Okay, so here's the 0 that I'm talking about. That's 0 right there. And so ray AE is on the 0. And so it looks like ray EB goes straight up to through that 90 right there. Okay, so this angle is 90 degrees. So let me see. Let's put 90 inside. Okay, so now if I want to measure this angle over here that I marked in blue, what is the measure of that angle? You can still position the protractor the exact same way we just had it because there's a 0 on the other end of the protractor. So you see the 0 right there. Oops, hold on. There's the 0. Ray ED is on the 0. And so I'm going to look at the 0 and I'm going to go up, and it's like at about, mine is about 51 degrees. Okay, so 51 degrees. Yours might be slightly different, okay, because I don't know that they print out perfectly the same. Okay, so if you're using your protractor at home and measuring the angles on your notes page, then that is probably not the same as mine. Okay, so there's one more angle to measure. And this one, I know you can probably add and subtract, you know, from 90 or 180, but what I want you to do is practice using the protractor. And what you'll want to do is, remember, we have to put one of the rays on the 0. So you have to turn it this way or turn it that way to where one of the rays starts at 0. Okay, so it doesn't matter which one you do, just as long as you've got one of them on there. Okay, so when I line it up on the 0 and I count 10, 20, 30, looks like at 39 degrees, that's how much that angle is in that little section, 39 degrees. Okay, so using this protractor, you have to make sure you line up one of the rays with 0 and then just count across or just look up from 0 to however many degrees the other ray lands on. Okay, so you'll have that on your homework, but we have a pre-printed protractor for you. Okay, next term, angle bisector. Okay, so you heard of the word bisector in 1.1. Remember, bisector came from when we were talking about midpoint. So it's a midpoint that divides the segment directly in half. So an angle bisector is a ray that divides the angle into 2 equal parts. It's a ray that divides the angle into 2 equal parts. Okay, so in this case, 2 congruent angles. So it's going to be right down the middle. So right here, we have this angle, angle DAG. And over here to the right, it is saying that angle DAW, so DAW, this angle right here that I marked in red, is congruent to angle WAG. WAG. And so since they're equal to each other, so I'm going to put a little tick mark like that, that means this ray right here is an angle bisector. Okay, so AW, how do you name a ray? We did that in 1.1. Ray AW is an angle bisector. So you can use the angle symbol whenever you refer to an angle. Okay, so that's an angle bisector. Next one, skew lines. Just to give you a heads up, most students tend to forget or have a little bit of trouble understanding what skew lines are. Skew lines are lines that do not ever intersect and are non-coplanar. So the word non-coplanar was one of our vocabulary words in 1.1, and so that means they're not on the same plane. So let's take a look at this picture below. So on this picture, you have a picture of a prism, okay, or a box, and you have a line up going up here, which we'll call that line M. Okay, so label your picture. And then we have a line down here along this edge, we have that called as line T. So this one is way up here and this one is down here. They fall under that category of not intersecting and they're non-coplanar. Now, some people are probably thinking right now, well, wait a minute, if we extend that line this direction and we extend this one over here, it appears as though they are going to intersect, okay? So does it appear as if they intersect? You have to have a three-dimensional mentality, okay? So even though it appears that they intersect right here, they don't, because you have to think 3D. So these are not going to intersect because this one is technically, line T is technically below and under it. So let's talk about that. Let's say you're probably in your bedroom right now. So imagine in your bedroom, you have the top of your ceiling and where it meets one of your walls. Look at that line going across that edge. And now look at a line in your bedroom that is intersecting with your floor and one of your walls. Would that line towards the top of the ceiling ever intersect that line on the floor? Now, of course, on an opposite, on one of the other walls. Okay, so it can't be parallel with that. So I know it's kind of hard to imagine that in your room right now, but if you can just kind of think and look around in there and see which two lines would not intersect and are not on the same plane, meaning not on the same wall of your bedroom, those would be skew lines. Okay, so I'm going to go ahead and kind of cross that out because they do not intersect because one is lower than the other. Gotta think 3D. Okay, these are easy. I think you definitely worked with these in middle school, probably 6th grade. A right angle, an acute angle, and an obtuse angle. Okay. So let me pull these up. So obviously your right angle is going to be a measure that's exactly 90 degrees. An acute angle is an angle that measures less than 90. And then your obtuse angle is a measure of an angle that is greater than 90, but less than 180. Okay, so it's going to be less than 180 because if it gets larger than 180, then you're looking at what we call is a reflex angle. Okay. So just obtuse, just bigger than 90, but less than 180. Adjacent angles. You might have heard of this word adjacent, and these are angles that share a common ray. So adjacent. I like to think of it as just being right next to. So I hear a lot of kids in the past say, oh, it just means they're right next to each other, and that is correct. So they share a common ray. So I'm going to call this angle 1, and this one angle 2. So angle 1 and angle 2 are adjacent. So if you hear your teacher say the word adjacent, know what they're talking about. Okay, so it just means right next to. Complementary angles, I think this is another term you might have learned in middle school. These are two angles whose sum of their measures is 90 degrees. So I have two pictures, and I think they're on your notes also, or you can draw them if you're just writing your notes out. They can be adjacent, like over here to the right, the 40 and the 50 degree angle, or they don't have to be adjacent. They can be just totally separate different angles. As long as they add up to 90, they are complementary. Most teachers in the past draw a little line over here on the C, and it makes a 9 to help you remember that complementary represents 90. And the little zeros right after that, so it looks like 90. The next one is supplementary. These are going to be two angles whose sum of their measures is 180 degrees. So on the left over here, you have a 125 degree angle and a 55 degree angle. And then to your right, you don't have any measures, but you have, let me get my highlighter, a flat line. So this flat line right here represents 180 degrees. So if you look at your protractor, it goes from 0 to 180 because that's the flat line. So these two angles right here, this one and this one, those two add up to 180. So they are supplementary. The way you can make an 8 with the letter S is just draw a line like this, and you have an 8, so that helps you remember that the 8 comes from 180, and they add up to 180. All right, next term, vertical angles. Vertical angles. We're going to come up with a definition after I identify these vertical angles, okay? So we're going to write them down. So I have some examples that are going to be pairs of vertical angles. I'm going to have some over here to the right that are not vertical angles. So this first picture on the left, you have angle 1 and angle 2. That is a pair of vertical angles. So I'm going to kind of color coordinate here. So that angle and that angle, they are vertical. Let me get a different color now. This one here, angle 3 and angle 4. That is another pair of vertical angles. So notice the two that I just gave you, they're directly across from each other on opposite sides. So let's look at this one over here on the next picture. This angle here, angle BEA, is vertical with angle DEC. Okay, so angle BEA and angle DEC. Those are vertical. Okay, one more color. This angle here, and directly opposite of that is angle AEC and BED. So angle AEC and angle BED. Okay, so those are all examples of vertical angles. Okay, these over here to the right, these are not. 1 and 2, those are not. 3 and 4, they look like they could be opposite each other, but they are not. This one's very close to doing what we just talked about, 5 and 6, but these are not vertical angles. And same thing with 7 and 8, those look like they could be vertical angles, but they are not. Okay, so based off these angles over here that are not vertical and these that are, a good definition would be that they have to be created by intersecting lines. So you'll notice that in this picture. Over here on the right, the ones that we thought were really close to vertical angles, they were not created by intersecting lines. So that's how we're going to start the definition. So it's going to be two angles formed by intersecting lines. And I misspelled intersecting, so let me go back. So two angles formed by intersecting lines that are not, and we're going to use a vocabulary word, that are not adjacent. Okay, so you'll notice the two red angles that are vertical, they're not adjacent, nor are the green or that blue pair or that purple pair. Okay, so we're going to use that word. So two angles formed by intersecting lines that are not adjacent. Okay, and really we should probably say formed by two intersecting lines to be exactly correct. Okay, so those are vertical angles, and they're pretty easy to identify. Just think opposite of each other. Okay, one more definition. Actually, two more. Linear pair of angles. Linear pair. This one's a little different. So let me get a colored pen. So I'm going to just kind of color code. I'm not going to name them, but angle 3 and angle 1. Those two that I just colored in red are a linear pair. Angle 1 and angle 4, these two, is another linear pair. Angle 2 and angle 4 is another linear pair. And lastly, 2 and 3. 2 and 3, that is another linear pair. Down here, 1 and 2, that's a linear pair. Okay, and kind of the same situation over here. These two form a linear pair. These two me get a different color. These two. And if you have colored pens, using these, that's why we put them on our supply list. Using these colors kind of helps see it a little bit better rather than just pencil markings. So all of those are linear pairs. Okay, and again, I didn't write them down like angle 1 and angle 3. I'm going to write all of those down. I'm just going to mark them. Those are all linear pairs. Over here, these are examples that are not linear pairs. So 1 and 2, those are not. Angle A and B, those are not. 6 and 5, those look very close to being a linear pair, but they are not. And probably because this line right here is not technically a line, they're two different rays. And then 7 and 8, those are not a linear pair, even though we have a flat line down here because there's another angle. Okay, so what's a good definition? So what do you notice about all these pairs of angles? They are adjacent, so you notice that's different from vertical angles. So these are adjacent, okay? And they're going to be formed by a line. Notice this is always a line. Okay, so the angles are adjacent, and then they are formed by a line. So I had just highlighted that in purple, so you see this line. And then what is this called right here? When it starts here and it goes forever that way. A line and a ray. Okay, and I know you're probably saying, well, it doesn't have a line and a ray in the other two pictures, but they kind of do. Because remember, a ray is part of a line. So look at these for angles 1 and 3. Here's the line, and here's the ray. So see, angle 1 and 3 are right next to each other. They were formed by a line and a ray. How about 2 and 4? Here's the line, and here's the ray. 2 and 4 is a linear pair. Okay, and you can get different colors. Here's the other way around. Here's the line, and here's the ray for 1 and 4. 1 and 4 is a linear pair. Okay, so that's going to be our definition for a linear pair. So two adjacent angles, because they're right next to each other, formed by a line and a ray. Okay, angle addition. This is going to be very similar to segment addition that we did on section 1.1. Okay, so it's almost pretty much the same thing, but just with angles. So we have this angle here, angle CAB, and then we have an orange ray that is in the interior. And so if that ever happens, okay, if D is in the interior, then we have, let me color coordinate, let me get my highlighters. Then angle CAB, so that I'm going to color in yellow right here. Angle CAB, which is this angle here. That angle is the big angle. And so if we add angle CAD, which is this angle here in pink, that angle there, CAD, we add that with angle DAB, which let me highlight that, DAB. Then those two added together is going to equal angle CAB. Okay, so the measure of those angles. So let's put a little bit of numbers to it. So if this is angle 1 and angle 2, and the big angle is angle 3, angle 1 plus angle 2 is equal to angle 3. Okay, so we're going to do some examples with this. Here's the first one. So it says if R is in the interior of angle AXS, you probably want to draw that right off the bat. Okay, because sometimes it's kind of hard to see. So I'm going to draw an angle, and I'm going to label it AXS. You know what? I want to draw a larger angle so I can label inside. So let me make it a little bit bigger. Angle A. Vertex is X because it's in the middle, and this is S. And then it says R is in the interior. So R is somewhere in the interior. That point is R. That's A. And then I don't always have to draw a point for you. You can just put the letter there. Okay, so let me get a different colored pen and let's label what we have. Angle AXS is 76 degrees. AXS. So the whole entire angle, the big angle from there to there is 76. Okay. Let's pick another color. Angle RXS, that's this one right here, is x plus 12 degrees. So we're tying in the algebra so that way you can practice your algebra still. And then angle AXR, this one here, is 7x plus 4 degrees. So they want us to solve for x and find the measure of the angles. Okay, so the blue angle and the green angle, we don't know what those are, but we do know the big red angle, 76. So how would you set this up? You want to use your angle addition. So the green angle plus the blue angle adds up to be the big red angle. Okay, so if you want to do a little picture, see the green angle plus the blue angle equals the red angle. Okay, see a little color coordination. So now we're going to just write it out algebraically. Okay, so we have 7x plus 4 plus x plus 12 equals 76. Let's do a little bit of, what do you call it? Adding like terms, combine like terms. So we have 8x plus 16 equals 76. Subtract 16 from both sides. 8x equals, what's 76 minus 60? Divide by 8. Okay, so x is going to equal, 8 goes into 60, 7.5 times. Okay, so x equals 7.5. So I'm going to highlight that as one of my answers. And then we also have to find the measure of each angle. So we're going to have to plug that number in. We're going to plug that number into each one. And make it a different color. And see what we get. So I'm going to plug it into this bottom one down here because that looks super easy. 7.5 plus 12, that's 19.5 degrees. You can do that in your head, right? So that's 19.5 degrees for angle RXS. And so this angle over here up at the top, I can just subtract 76 minus 19.5 degrees, and that's 56.5 degrees. So I found each angle, measures, and I solved for x. So that's how we're using angle addition, okay? Let's try this next one. It says if angle ABC is 5x plus 32 and ray BD is the angle bisector of angle ABC. So let's draw that picture right here. Okay, so I'm going to draw a really big picture. So this is angle A, B, C. And it says BD is a ray, so you want to try to draw it right down the middle. And so since it's a bisector, okay, right here, angle bisector, I want to mark these two angles equal. Okay, so those two angles are equal. The top one looks smaller than the bottom one, but as long as you mark them equal, then you should know. All right, so the whole thing is 5x plus 32. So from here all the way to there is represented as 5x plus 32 degrees. All right, and then it says angle DBA is 4x plus 4 degrees. So I'm going to get a different color. DBA, so this one right here. This one is 4x plus 4 degrees. Find the measure of all the angles. Okay, well, we just marked that these two are equal. So since they're equal and we have a representation for angle ABD, this angle down here can also be represented as 4x plus 4 degrees because they are equal, because this is a bisector, an angle bisector. So now we have a representation for each angle, and we can set up our angle addition. Okay. So I know that if I take 2 times 4x plus 4, that's going to equal the red angle, 5x plus 32. Okay, or you can write out 4x plus 4 plus 4x plus 4 equals 5x plus 32. So then we have 8x plus 8 equals 5x plus 32. Now I've just become some algebra now. We have 5x over here, so I'm going to subtract 5x from both sides. I have 3x plus 8 equals 32. I'm going to subtract 8 from both sides. So 3x is equal to 24. Divide by 3. And x is going to equal 8. Okay, so there's x. That's not what they want us to solve for, but I need to use that 8 to plug it back in and find each angle. Okay, so if I can just find one of those blue angles, the rest should be pretty easy. Okay, so let's plug in 8 for here. If I plug in 8 there, 8 times 4 is 32. 32 plus 4 is, see, 36. So this little angle right here is 36 degrees, which is also over here. And then the whole big angle is 36 times 2, which is 72 degrees. So we found all the angles, 36, 36, and 72. All right, last example for these notes. It says angle ABC and angle BBA are complementary. What does complementary mean? You draw a little line right there, it makes a little 9, so that means we're working with them adding up to 90 degrees. We have a representation for each one. It says find the measures of the angles. Okay, so ABC is 3x plus 4. BBA is 6x plus 7. And we're going to add those two and set them equal to 90. Combine like terms, 9x plus 11 is equal to 90. Subtract 11 from both sides. 9x equals 80, nope, not 80, rewind. 79. Divide by 9, divide by 9. X equals, let me get my calculator because that's not evenly dividing, 8.78. Okay, just to be sure, I know everybody always freaks out when we have decimals, so let's go double check our work just to be sure. ABC, BBA is 3x plus 4, 6x plus 7, 3x plus 6x is 9x, 7 plus 4 is 11, set it equal to 90, minus 11 gets 79. Yeah, okay, that's okay. So we get a decimal, 8.78. And so now let's plug that back in to each one. So I have it in my calculator. I'm gonna plug it into the first angle. Let me get a different color. Angle A, B, C. So that's 3, and we're gonna take that 8.78 and plug it in for X, and then add 4 to that. So I'm gonna times that by 3. I get about 26 and a third. And now I'm going to add 4 to that, plus 4. So angle ABC is equal to 30.33 degrees. Okay, 33 and a third. Okay, and so I just have to subtract that from 90, and that'll be my angle. Let me get a different color. That'll be angle DBA. So we get 59 Okay, and so I always like fractions, so this would be 30 and 1/3 degrees. This one would be 59 and 2/3 degrees. You do not have to leave it in fraction form. Decimal's perfectly fine. Okay. And that concludes these notes.